We're going to review data structures in Python, going over strings, lists, tuples, and dictionaries. Talking about strings first, what's the difference, say, between a string and an integer? So at the beginning of this file, I've defined an integer, x equals 1, and I've defined a string, y equals 1. And they look similar, and they both somehow represent 1. But the difference is the difference between a number and a numeral. So a number is, well, it's the number 1. It's a number that you can add, subtract, and have interact with other numbers, versus a numeral, which is a representation for that number. So in this case, in the US or other countries, we represent 1 using this symbol, but in other places you might represent it with a single vertical bar. For example, if you're counting with Roman numerals, you might do that for 1, that for 2, that for 3, and so on, and that for 4. So the differences between a representation versus the actual concept of the number. So in a computer, everything ultimately is represented in terms of ones and zeros. It's represented in binary. But how we interpret that representation depends on whether we're interpreting something as an integer or as a string. And with strings, you can tell if you have a string because it's enclosed in quotes. And that tells Python, oh, I'm going to interpret this thing as a string. Strings are the basic currency of Python for input and output. If you are going to input something from a keyboard or type something in, if you're going to input something from a file, or if you're going to output something to a screen or output something to a file, then that's always done using strings. And then if you needed an integer or some other data structure on the other end, you'd have to do a conversion back from a string to whatever other data structure you're using. Okay, so just messing around with a couple strings here at the beginning. What are strings? That actually should end with a question mark. The ubiquitous hello world and adios amigos. We can print those two strings pretty simply out to the console or computer screen, as you guys probably know it, just using a simple print command with a string in it. And we can also ask what the length of those strings are, just using a simple length command. If you want to delve further into a string, and I'm have put headers on all the different topics we're covering in strings here. So I have the what are strings, string indexing, string methods. Notice I have a \n at the beginning of this. That's going to give me a new line to sort of pretty things up a little bit and make it easier to follow along when we actually do the output. Let's go ahead and run this. So in PyCharm, we'll come up here and run. Make sure you got the right file. I want to run strings.py. So we'll run that. And so here's the output, what are strings, hello world, adios amigos, and there's 11 characters in hello world. And then we go to string indexing. So notice that every time you execute a print command, you get a new line. And then with this \n, it actually gives me an extra new line. And I go to string indexing. And I can make S3 equal to, so when you index, you can count the elements of a string, or as it turns out, lists, tuples, and so on. And this counts always start with 0. That's pretty standard in computer programming. So if I ask what is the 0 index, or what is at the 0 index in string 1, I actually get another string, S3, which I can print out, and it's just the first letter H. You can get a range of indices. You have to be a little bit careful with ranges in Python. So at the second index in hello world, 0, 1, 2, I should get an L. The third index, I'll get another L. And then this says 2 to 4, but with Python, it always goes up to 1 less than that last number. So it's only going to go from 2 to 3. I'm only going to get the 2 L's, and that's right there. You can go from 2 to the end of the string by just leaving the second argument blank after the colon. So this will go from 2 to the end of the string, and that'll go LLO world. And then S5, well, that was S5. Okay, so then We can go from the beginning up to the 8th. Well, this won't actually go to the 8th, right? This will go to the 7th index. So we get hello, whoa. You can do negative indices from -3 to -1 is actually going to give us something at the end of the string. So we'll go back -3, -1, -2, -3, and then it goes to -2. And then remember, we don't get the very last -1 in there, so we're only going to get R and L. And then finally, if you wanted from -3 to the end of the string, we just do as we did before, starting at -3 and then go all the way to the end, and that'll give us the RLD. There are different methods that you can use on strings, and if you're familiar at all with object-oriented programming in Python, then you know what a method is. We're going to get into that in the very near future. But for right now, these are just operations that you can do on strings. You can do what's called a concatenation. You can put two strings together. So I can add string 1 and string 2. And if I do that, then we get hello world, adios amigos. Notice that the string concatenation doesn't automatically put a space in between. So we go right from hello world right to adios amigos, no space. If I wanted to put a space in there, that's something I'd have to do myself by doing this and concatenating another string in between the two. And we can do that. So now we have a space in between hello world and adios amigos. And then I've indented these other over from, well, I indented, when I printed this out, I indented the string S6. So S6 was the concatenation of S1 and S2. So that's the hello world, adios amigos. And then I indented that over by concatenating in front of this string S6 a few spaces just to kind of indent a little bit. Hopefully make it look a little better. And the concatenation is indented from the main header string methods. Not terribly important, but just pointing out some techniques if you wanted to do some kind of indenting to try to make your output look a little better. There's a simple way to do that, and that is to just put blanks in front of it. You can just do a single blank. I've got 3 blanks here. I could do a single blank and actually just multiply that by 3. It'll give me the same number of blanks. In this one, I've taken S1, which is hello world, and then added on to it the first few, well, actually I skipped the first character of S2 because that would be 0. So we're going to the 1 index. That's actually the second character up to the 3rd index. So we get hello world, and then from the adios amigos, we get just the DO. And then if you want to do capitalization kind of things, there's a method called upper, which will capitalize the entire string. Lower will capital or lowercase, put the put the entire thing in lowercase. There's a title, which will put the first letter of every word in uppercase. And there's also a method, if you want to look this up, there's a method to put just the first letter of the first word in uppercase. So there's different ways to handle capitalization techniques. This is actually very useful when you're doing an input, somebody's inputting their name or something like that. Some people might type the entire thing in capital letters, some people might type the entire thing in lowercase letters, and what you really want is a standard, want to be a standard way or standard input. So just take whatever they type and throw it into upper, lower, or title, or whatever your preference is. Sometimes people will type in things and you want to pull pieces out. So this is a simple example of, here is a character string I just made up. The A, the D, and the S are close together on the keyboard, so it's just convenient to type this. And then you can take off the A's. Now when you do a strip command, so the command is a string and then dot strip. Now up here, And notice that you can do this two different ways. You can apply a method two ways. Up here I had defined a variable s2 as that string and applied dot upper. And down here I'm just using a string and doing dot strip. Either one of these methods will work. And that do the dot strip, or you can just use the string as it is. Depends on what your needs are, what the context is. But the important thing is, this strip command doesn't take all of the A's out. What it does is strips the stuff from the beginning and strips the stuff off the end. So it's going to take these first two A's, take those out, take this last A, take that out, and I should get DDAASS, which is right there. You can also just take the A off from the right side, doing an R strip, or take the initial two A's off from the left side, doing an L strip. So you see those outputs. And then and we're supposed to get into conditionals in another section, but this is supposed to be a review, so you should have seen if statements before. You can also use an in command, and we can say, is the letter A anywhere in the string at all? So we ask, is A in here? And of course the answer should be yes. And if it is yes, we print out this string contains an A, and if it's not in here, we're going to print out this does not contain an A. And of course we find that it does. You can actually locate an A by doing a find command. This will give you the first A that it finds. There are ways to find the other A's by doing strips. So I find an A is at the first index, and I could take that first position off and then find the rest of the A's, but that's a different programming problem. But there is a way to find characters in a string. Okay, lists. Lists are very useful. We use these a lot in programming. To make an empty list, it's just there's two ways to do it. You can make an empty bracket, or you can, here's a second way to do it, you can just declare an empty list like this. If you want a non-empty list, you can say something like L2 is, and this is a list of strings, one character strings. In other languages we call those characters. Lists are indexed the same way that strings are, and it's the same way that tuples will be. I'll go over those in a second. If you want to add something to a list, then you do an append command. So I want to append the number 1 and the number 2 to L. And then we're going to print out what L is, and we're going to print out, there's other methods we can use on lists, like the string. We can ask what the length is. We can ask for the maximum value in a list. Let's go ahead and run this. So I'm going to go over, and I have lists, I've already run it, so it's over here. I can run this. If you haven't run a program before and you're not used to PyCharm, lists wouldn't appear here until you actually run it once. If you just right click inside of here, you can run lists at any point. And okay, so the first print here is the length of this empty list, which is 0. And then we're asking what is at index 1 in this list. That's actually the second element of the list, again, because we start at 0. So that should be the character B, or the string B. Now we're going to add some elements to our list again. We talked about this, appending numbers to our list, and we can print out a list, L, 1, 2. We can print out the maximum element of L. We can ask what is at the second index, or no, I'm sorry, we can reassign the second index of L2 to be D, and then if we print out L2, so originally we had A, B, C, and at the second index 0, 1, 2 we had a C. If we reassign that, we can make that a D. What I can't do is that it won't let me create a third index. This has length 3 already. It won't allow me to add an element to the list doing this kind of notation. You have to use the append command to do that. So let me get rid of that before it gives me an error. So you notice that when we print out L2, we get A, B, D because I've changed the second element, or well, that's actually the third element, the element at index 2. And that gets into this whole discussion of whether lists are mutable or immutable, strings mutable or immutable. That's going to be another conversation that we're going to get into in the very near future. You can remove things from the list. There's two ways to do a remove here. So let's go back up and look at the list L. And oops, L is the list that has a number 1 and a number 2, not numerals. These aren't strings. These are actual numbers. Number 1 and number 2. And I can say remove 1. This 1 is not an index. It's saying go in and find the element 1 in this list and remove the first case of it. And so when we do that and we print out, when we print out L again, we get a list that has just the number 2 in it, so it only has one element in it. Now we print out L2, and then there's another way of deleting elements or removing elements from a list. In this case, I'm saying remove the element at index 1. And so that was the B. It takes the B out, and now we have A and D. D is now the element in index 1. And then finally, you can do a split on a string, and that will return a list. And you can split on any character or any string that you want. So in this case, I'm splitting this string on the letter A. And so what it's going to do is go through and look for a single occurrence of the letter A. And then it will split. It'll take everything before that A and everything after it, and make those into two separate strings and put them in a list. But now this long list here, it's going to go through that, look for A's, split it, so we'll get an SS and the DDFGA. Oops, I just moved something. And the DDFFGA, it's going to go look for the A again, find the DDFFG, make that a string, and make everything after the A another string. And it's going to return a list of all those separate strings that were split by the A. So we get the S, the SS, the DDFFG, and finally an empty string because there's nothing after this A here. We could do a split on SA. Let's see, we got SA at the beginning and SA here, so there's two places where there's an SA. And we should get an empty list at the beginning. And then there's an S here, in between this SA and this SA. And then finally the DDFFGA at the end. So just remember that you can split strings. This actually turns out to be useful when you're doing inputs. The simplest example, we did this one last semester, is if you're inputting a Social Security number, it's separated by a dash. And to check that if you have a valid Social Security number, you might want to break that up into its three different components, the 3-digit, 2-digit, and 4-digit components. And the simple way to do that would be to split a Social Security number on a dash. Okay. Take a quick look at tuples. One thing we're not doing in this is talking about when or why you would want to use these different data structures, and that's stuff that we're going to get into a little bit more as we go along and continue the review. A tuple is similar in a lot of ways to a list. It's defined as with parentheses instead of brackets, or you can define using the tuple command. It's indexed the exact same way as a list or a string. There are differences between tuples and lists that are important, and we're going to get into those as we go along, but again, not right now. If you want to add a tuple to a list, that's very different than adding something to if you want to add something to a tuple, it's very different than adding something to a list. So there's a couple ways to do it. One's much more complicated than the other. I'm not sure exactly. Well, there could be reasons for doing it this way. But in the first case, to add to a tuple, the only way to really do this is to take your original tuple, in this case T3, and add to it another tuple. You have to make it a tuple, and the way you do that is if I wanted to add the element 4 to this tuple, I have to declare a tuple that only really has the element 4 in it, and a none or nothing here. So this comma here is very important, and it has to be here to make this work, and it has to be inside of parentheses. And one of the differences here between lists and tuples is this actually creates a new tuple in a way, and we're going to see this later on. If you do this with a list, you don't get a different list, but with a tuple, it creates a new tuple. Okay, so again, we're going to go into that later. It's not important right now. But here's how you add elements to a tuple. Another way to do it is to actually take the tuple, convert it to a list. So there's a command list that takes a tuple and converts it to a list. So now we have a list L3. You print that out. Then you could append to your list and then convert the list back to a tuple. Now if you had a lot of appending to do, or a lot of adding to a tuple to do, this might actually be a decent way to do it. You wouldn't convert every time. You convert initially, do all the additions you needed to do, and then convert back to a tuple. How do you remove elements from a tuple? It's possible, but if you need to remove stuff, you probably should be using a different data structure than a tuple. So we're not going to go over that. Tuple methods, yeah, there's not a lot there for tuples. Tuples have a very specific purpose. Again, we're going to go into that, but just not right now. While I'm in here, PyCharm over here on the right has these little white blocks, and these are telling you that there's not necessarily a mistake in your code, but the way that you've written your code is not the way that it's not Python-esque. So when you write something like this with an equal sign, you're supposed to have spaces in between, and I didn't have them, so it complained, and I put spaces and got rid of those little white blocks. Okay, completely nothing to do with tuples at all there. All right, dictionaries are the last thing. Dictionaries are really cool, much more general than strings or lists or tuples. In that dictionaries, well, first to declare an empty dictionary, these are declared with braces, or you can use the dict command. If you want a non-empty dictionary, then it's declared with braces, and then you need a bunch of things separated by commas, and each one of those is a key and a value, and the key and the value are separated by a colon. And again, it's yapping at me because I don't have a space after the colon, so it gets upset about that. It's easier to just listen to PyCharm and stop getting those balloons popping up all the time. So what's special about a dictionary? Well, dictionaries are not indexed by integers. Strings, lists, tuples are all indexed by an integer, 0, 1, 2, 3, 4, and so on. Dictionaries are indexed by keys. Now in this case I've used integers as my keys, so this may not have been the most brilliant first example, but we can print out this dictionary D1, and here we'll get basically exactly what we typed in. We can ask for the value, so this should give us an S. The value at index 1, and we've declared that to be an S, so we should print out an S here. And then D2 is an empty dictionary, so we don't get a whole lot there. Now, different from lists, I can add a new key and value to this by doing a declaration. I want, for the key value 3, I want the value to be world. So this is actually creating a new part or adding to the dictionary. Another way to do that is to do an update. So there's an update command. If I wanted to add a quote from Mr. Sulu, oh my, to my D2 dictionary, then run the update command. Inside of this you have to have a dictionary. So this is in braces, colon. This is the key value. Notice that you can use a string as a key. So this is very different from, again, strings or lists or tuples. The key now here is oh my, and the value is Mr. Sulu. And so I can print out D1. D1 now has added to it the key value 3 and the value world. I can print out D2, which is just oh my Mr. Sulu. Something I didn't do in here, but I am going to add this in just to sort of emphasize the fact is we can ask for the value for the key oh my. And so that should give us Mr. Sulu. He's the guy that said it. Wow, maybe it's the actor. Anyways, making a new dictionary D3, and this is one I just pulled out of, I forget where I got this from. So again, you can have strings that are keys, and then you can have anything over here that you want for values. In this case, there's a bunch of integers, so I can print that dictionary out. So another way to add to a dictionary, and we've done this above, is you can just declare the dictionary using the dict command, and then this is actually a list. You can remove elements from a dictionary using the delete command. So I'm going to remove the key value pair corresponding to the key 2 from D1. And then when we do that, we no longer have the 2 hello in this. And as far as methods go, you can again use the in command. So we can ask is SAPE a key value inside the dictionary D3, and we can see that it is, and if we get back true when we print that out. So the value for the in command is going to be a true or a false. One last quick thing with dictionaries: when you print these out, the order on these is not guaranteed. That's kind of a weird attribute of dictionaries. When you do this print, this could print 2 hello, 1 s, 3 world. You have no idea what order you're going to get these things out in. So don't expect these things to be ordered if you're using a dictionary. Okay, so there's a quick review of the different data structures that we are going to need this semester.